Alright, so in this app today we're going to do a crash course or introduction to SQLite databases. But we're not going to do just databases, we're also going to do a whole slew of other things in this application as well, from not only learning how to create a SQLite database at the command prompt, but also we're going to learn how to do page navigation without using segues or a button. We'll use segues, but we're not going to use a conventional button to do our segues. So you notice that there's a save button on the screen, but there's two labels below that say navigate to the following pages by clicking on those labels. So we're going to know how to click on those labels to navigate to the following page. And if we click on view database using table, it'll navigate to a database. It'll navigate to listing our database entries from a table perspective. And then if we click on view database using picker, then it's going to navigate to a page where it's going to show us what it looks like using a picker, so the entries we have in our table. But we're also going to take it a step further and look at user defaults. And user defaults is a very handy saving mechanism where you can save data and load data quickly on the fly for small little bits of data. And we're going to use it to remember previously entered information, which will make things nice and convenient. So what we're going to do now is we're going to get into creating our SQLite database at the command line. So what I want you to do is open up a terminal, which you can find in your Launchpad, and you're going to type in the command SQLite3 mydatabase.db. And what it'll do is it'll put you at a prompt. And this prompt is essentially for editing the SQLite database you just created, and that database is called mydatabase.db. So what we're going to do is we're going to create a small little table inside our database that will house the information that we're going to bring in to our iPhone app. So the first step to do is to create a table, and in that table we're going to say create table entries. And our table is going to have 4 columns. The first column is going to be an ID column, which will be integer, and it'll be primary key. Then the second entry, or second column, will be name, and it'll be text. Now, SQLite differs from your conventional SQL, so you're going to see that the column types here will vary. So text is what we consider varchar. Now the third column is email, which is also text. Food is also text as well. Close the round bracket and put a semicolon. Now if you forget to put a semicolon, you might see an odd prompt, and that's okay. Just type in a semicolon there, hit enter, and you'll come back to your prompt. So now at this point we have a 4-column table that has 4 items, ID, primary key, and it has name, email, and food, which are all text. So what we want to do now is we want to be able to enter in some raw data that we can use to in a nutshell, do a proof of concept that we can actually receive data into our iPhone app when we actually open up and connect to this database file and bring in the data accordingly. So we're going to do an insert. So we'll say insert into entries, values. Now for the ID, we want to auto increment, and the best way to do that is to type in null. That triggers SQLite to go ahead and auto increment our ID column, so we don't have to worry about entering a number for us. Now our first entry will say name is Munkee. We'll say email is munkee@projectmkd.com. Then we'll say that Munkee's favorite food is bananas. Close that round bracket, semicolon, hit enter. Now let's just verify that it's in our table by saying select star from entries. And we see one row of entry, 1 as the ID, so it auto incremented. We got Munkee at projectmkd.com, and Munkee likes bananas. Now the next step is to maybe another row as well. So just to see more data, so we'll say insert into entries, values, null to auto increment. This time we'll say llama, and we'll say llama's email is llama@projectmkd.com, and we'll say llama's favorite food is hay. Close the round bracket, semicolon, hit enter. Do another select star from entries to verify that llama's entry was there too. And now we see 2 lines of information, so Munkee and llama, row 1, row 2. Let's insert in one more row, so saying insert into entries, values, null again to trigger $increment, and we'll say Yoti. And Yoti's email address is yoti@projectmkd.com. And we'll say Yoti likes to eat steak. Closing round bracket with semicolon, hit enter. Let's do another select star from entries just to verify that our information is there. So we see 3 rows of information. We see Munkee, llama, Yoti, column 1, 2, 3, each likes banana, hay, and steak. So at this point, I think we have enough information, we have enough to go with to work with our database. So what we're going to do is we're going to save it and flush the data to our database file by typing in .quit. So it's important that we type in .quit and not do Control C to exit out, because we would lose the data we entered. We want to ensure that we are actually flushing our data to the file system, and in particular to the file, mydatabase.db. So a .quit command is perfect. But before we quit, I'm going to type in .help just to show you the additional commands that are available at your disposal so that you can use to test out and go further with this program and see what else is in there. So now we'll do .quit. Go to the file system, do it ls-al for mydatabase.db, and you should see one file, about 8.1 kilobytes of a file there. And now what we can do is we can actually use this mydatabase.db as our starting point for interacting with the database app that we're about to build. So you can just double check the location by typing in pwd, so it's at your home directory in this case. And now that we know exactly where mydatabase.db is, we can go ahead, pull this away, and start into our iPhone app. So now what we'll do is a file, new project, and we have iOS. We'll do a single view app in this case. Hit next. We'll type in that our project name is my SQLite database app. And we'll hit next and give it a home. And so now we're going to organize our files into groups because we'll have quite a few files to work with. So we're going to start off by creating our first group. So new group, right click and new group. And this new group will be view controllers. And we'll hit enter. And as we're creating groups, you may want to notice that the names of these characters are from projectmkd.com, so Munkee, Kissin, Dunkee 2. Fun game out there that definitely take the time to download, enjoy, and tell your friends about it. And it helps by you downloading it and supporting the app. You also help us to bring more tutorials into the fold so that we can bring you more educational materials. So definitely do share it with your friends, download, enjoy, and have fun with that game. So the groups we're creating are view controllers, classes, storyboards, and database. Let's just move our files into the correct categories. Alright, and so we have here all the files we need. First thing I want to do is I want to bring in my database file. So I'm going to right click on database, say add files to my SQLite database app. Navigate to where your database file is and bring it in. Alright, so have my database.db. It's now added in. Make sure you had copy items if needed checked off. Now I want to start into my storyboard. And to do that, I'm going to have a 3-page app. So therefore I want to bring in 2 more view controllers. So I'm going to right click on view controller and say new file. iOS Cocoa Touch class, subclass of UI view controller, and I'll call this one table view controller. So we won't use the UI table view controller object just yet. We'll use it in the future. So we'll just manually add in our table methods, which isn't a big deal anyway, just to illustrate how to do it manually if we needed to. So hit next. and give it a home. We'll add one more. So new file, iOS Cocoa Touch class. This one will be Pickerview controller. So it's also subclass of UI view controller. And we'll hit next. And give it a home. Alright, so now we have our view controllers. So now we can go ahead and set up our storyboards. Starting with launch screen. Just going to put a label in just to say loading. And then move over to main.storyboard. Put a title at the top. And this title will be Intro to SQLite Databases. And I'm going to actually copy that label and paste it twice towards the bottom of the screen. And this first label will say View Database using table. Second one, View Database using Picker. Okay. Now let's add some text fields. So I'm going to add 3 text fields for name, email, and food. So just copy and paste. And a button. We'll put the word save there. Alright, so that's the first page. Now, let's take care of the second and third pages. So I'm going to drag over a view controller here. First thing I do is I'm going to subclass this to be table view controller and not UI table view controller. Be very careful. This is our own customized table view controller. And I'm going to throw a view controller over here. So I can zoom out so you can have a better picture of what's going on. There. So that's table view controller. I click on the yellow circle for this new view controller I dragged in. I'm going to subclass this to Picker view controller. So now I have table view controller, Picker view controller. Now let's create the views. So I'm going to add in a nav bar for each. And I'll just say table view. And for this one, I'll say Pickerview. And let's put a back button in each. So we'll say bar button item. And I'll put the word back for each. Now let's just zoom in to table so you can see, or to each screen, so you can see table view has a nav bar with the word table view and a back button. And then Picker view has a back button as well. Now let's put a table for the rest of the page for table view. Just fill it up. And we won't connect data source and delegate yet for the table view. We'll do that last. when we're ready to display data. And for the second one, second page, for picker. There's two options there. There's date picker, which is a pre-built picker view that has date and time and even a countdown timer. We're going to choose Pickerview. Just a generic picker view to work with. So now our screens have all the objects they need to work with. We're going to start by just creating the segues that we need to navigate. But because we're using labels, we're going to have to do segues the other way. So I'm going to bring in my document view. I'm going to collapse everything so it's easier to drag. We're going to create a segue from view controller to table view controller, and a segue from view controller to Pickerview controller. So I'm going to highlight view controller, hold down my control key on the keyboard, click and drag to table view controller, choose present modally, and also again hold down the control key, click, drag to picker view controller, choose present modally. And like the last exercise we did segues by hand, we are going to have to give labels to each of these segues. So I'm going to start with the first one we created, which if I click on the arrow here that goes between our home page and our picker view, so click on that, let it turn blue, go to the attributes inspector, the identifier is going to be home segue to table. So we need to remember that name because we're going to need it in code. The second segue, click on that, let it turn blue. We're going to say home segue to picker. So now we're navigating to the picker view. Now what we need to do is find a mechanism or create a mechanism so that we can navigate from the home page to each of these subpages in code. And to do that, we need to write some supporting code to get that up and running and get our page navigation up and running. So first off, let's do the easy part, and that is to get the Unwind segue done for the back buttons. So we're going to move over to viewController.swift, hide this, and we're going to start by creating our Unwind segue. So I'm going to say IBAction func unwind to home view controller. Segue is of type UI Storyboard segue. Alright, so we'll connect that up later. Right now, let's start coding up the ability to navigate to those subpages. So what we're going to do is create a couple of IB outlets for our labels. So we'll say IB outlet var LBL table extends UI label with an exclamation mark, and IB outlet var LBL picker with extending a UI label exclamation mark. So we'll start with these two variables, and what we'll do is we'll get into now creating the code that'll do our navigation. Within UI view controller, there are touch events that can be added in, and each of these touch events are just events that you can execute upon just touching anywhere on the screen. Doesn't matter where. These methods can be executed. So if I type in the word touches, or even just touch, so we'll look at touches began, touches ended, touches moved, touches canceled. You can look into the docs to see more about it, but touches began in a nutshell will execute if you touch the screen. Just put your finger on the screen. Touches ended will execute only when you've touched the screen, but only when you've let go of the screen, when your finger has left the screen and untouched it. That's the only time touches ended executes. Touches moved is when you're swiping across the screen or dragging across the screen. So that's when moved is done. Cancelled is used for when maybe maybe some sort of issue happening, like a system alert, as it says in the hint above, that would force you to cancel your touch. So any sort of system event that could override a touch, it'll execute there. Maybe do some graceful cleanup is what you need. We're going to focus on touches began for today. Now the argument that's passed in is called touches. It's a set object of type with a bunch of UI touch objects. Now the reason why it's a set and maybe not an array is because you don't really care about what's passed in, the order that is. What's passed in is a set of pixels. So wherever your finger has touched the screen, the pixels that are touching your finger will be returned back. We only care about getting one pixel out of those. And we're going to test to see if that one pixel resides within the bounding box of either of our labels that we had in our storyboard. So if I jump back to storyboard for a sec, we just care to see if, using this little hand as an example, we just care to see if one pixel exists within these bounding boxes. Right? That's all we're going to do. If it does, we'll execute the corresponding segue. If it doesn't, we don't care. We'll just do nothing. So jump back to viewcontroller.swift. First, let's retrieve one pixel. So we'll say let touch of type UI touch equal touches.first. Now, the set object has the capability to return back a random object within there. It used to be in Objective-C and an earlier version of Swift, you would say touches.anyObject, and it would randomly return back. In more recent versions of Swift, they changed that to touches.first. So first could still be a random object, randomly setting back the first object that it comes up with. So it's a new way of returning back a random object, a random pixel. Now we need to convert that touch object into a CG point. So like an XY location we can deal with. So we're going to say let touch point of type CG point equal touch dot location in view, and so the view we care about is self dot view with an exclamation mark. Now that we have our pixel, we have one pixel we care about, we need to see if that pixel exists in either of the bounding boxes for either label. So let's retrieve back the frame variable of each of the labels. So the frame variable has the XY width and height, which is what we need. So we'll say let table frame of type CGRect equal LBL table dot frame. And then let picker frame of type CGRect equal LBL picker dot frame. So either way, we have two frames, two boxes, we have a pixel. We want to see if that one pixel exists within either box. So the nice thing about the CG objects is that they have very powerful functions for simplifying checking for if things overlap. So we're going to say if table frame dot contains, and we'll take the first one here, we'll say point, and we'll just check to see if it contains touch point. If it does, we're going to execute our segue. So we'll say perform segue with identifier. Now you got to be careful about how you spell the identifier because it's exactly how you wrote it in your storyboard. In our storyboard, if I pop back for a sec, I'll click on that arrow, and we called it home segue to table. You can simply copy and paste if you want to save yourself the headache of mistakes in your typing. So my string will be home segue to table, sender, you can say self. Now another if will be if picker frame dot contains touch point, then also perform segue with identifier. And this time you could copy and paste from the other segue. So this segue going to the Pickerview, you copy and paste home segue to Picker. Sender is self. Alright. So now we have our segues, we have our touch events. What we need to do now is connect up our unwind segues for the back buttons, and then we can go ahead and give this a test and see if we have page navigation up and running. So switch back to main storyboard. Click on the back button, hit the control key on the keyboard, click, drag to exit, choose unwind to home view controller, and same here, click, drag, unwind to home view controller. Now last thing we have to do is connect up our labels to the labels we created as IB outlets. So I'm just going to click on my yellow circle for the view controller, go to my connections inspector. I have LB Picker, and I connect that to view database using Picker. LBL table to view database using table. Now let's give it a run. So if I click on view database using table, there's my empty table view, shows nothing. Hit back, view database using Picker. There's my empty Picker view with nothing there, hit back. So now at this point we've illustrated how to do page navigation without a button, but using segues and calling segues in code. Alright, so now that we got page navigation out of the way, let's focus on writing some internal code to get the SQLite database to interact with our app. So a lot of our work will happen inside the app delegate, but before then, what we need to do is we need to create a custom object that will house each row of data that will contain name, email, and food, and the ID number for the row. So I'm going to add a new class. So under classes, I'm going to say right-click, and I'm going to say new file, the iOS Cocoa Touch class, and subclass of NSObject. And I'll call this object data with a capital D. Hit next, give it a home. So we have the data object. Inside of it, all I'm going to do is create 4 variables. So say var ID of type int, var name of type string, var email of type string, var food of type string. Let's put a little initialization method, a constructor almost, by saying like func init with data, and we'll say the row will be I of type int. We'll say the name will be n of type string, and the email will be e of type string, and the food will be f of type string. And inside of it, all we'll do is just save ID is equal to I, name equals n, email equals e, food equals f. And that's it for our data object. All it's going to do is going to hold one row of data inside of it, the ID number, the name, email, and food. So now we can go back to our app delegate file and start to write the code to interact with the database. So I'm going to switch over to appdelegate.swift. And let's start by defining some variables that are going to support our SQLite data transfer. So we'll say var database name, type string. I'm going to hard code it to my database.db. And then we're going to say var database path of type string is equal to nothing. we don't need to set it just yet. We're going to actually figure that out in a moment. Var people will be our array of data objects. So data, we'll set it to be an empty array just to initialize. Now we're just about ready to start navigating for our database. But what we want to figure out now is we have this database file. It's inside our app, but realistically this file, mydatabase.db, it needs to reside on the phone's file system to be worked with, so that the phone has a copy of the file and will work with it and add items, delete items, update items as needed depending on what the user wants to do. Now, what we need to do is figure out where the documents folder is. So we're going to be doing some file manipulation here. There's an object called File Manager that can allow us to access the file system so that we can actually do stuff with the files. So first off, I want to figure out where the phone's My Documents folder is, or just Documents. So we can save this database file in the Documents folder. So I'm going to say let document paths, and I should note this is all done inside did finish launching. We're going to auto initialize configuration for our database stuff inside did finish launching, so that by the time we get to the home page, the database has been opened, we read data, and we've populated our people array above with the data. So first I have to figure out where our documents directory is located. So there is a method that is called ns search path for directories in domains. This will search through the file system of the phone looking for whatever you're looking for. So first off, I want it to tell me where the document directory is. So the My Documents in a nutshell are just documents. So I'm going to say .document directory. And be careful, do not choose documentation directory. Do not choose documentation directory. This is not going to work because you won't have write access to it, and so your app will crash quite often. So you need to do document directory because this is the directory you actually have access to as a phone user. So we'll say document directory, and document mask, like what user level am I at? So I'm going to say .user domain mask. I don't want anything more than that, just regular user. Expand tilde, I'm going to say true. Because I want the full path. I don't want it to say tilde/documents. Now what this method does is it returns back an array of directory paths. And what that means is that it'll return back not just your documents location, like /user/documents. It'll also return back like /user/documents/video, /user/documents/pictures, /user/documents/ etc., etc., etc. So it'll return back a whole array of paths. Luckily, the first index in that array is our base document directory, which is all we need. So I'm going to say let document dir equal document paths of 0. So I just want the first index. Okay. So now that I have that, I'm going to append my database name to, I'm going to say database path is equal to documents dir dot appending. Now we have to append a slash as well as database name. Alright, so the reason for that is if I append database name on its own, it's going to actually join it to it'll say document mydatabase.db as one big word, and the app's going to crash. You're not going to find your path properly. So you need to append the slash there. So in Objective-C, there was a method that appended path component, which actually automatically inserted the slash for us, but it's not here, unfortunately. So at this point, at this line of code, we now have a location to point ourselves to for where the My Documents folder will be on our phone, and even on our simulator, as we're going to illustrate here. So now, the next step is to actually figure out if the file already exists. If it already exists, we won't do anything. We'll just continue accessing the file at that location. But if it doesn't exist, meaning this is the first time we've installed the app and we're running the app for the first time, the file most likely does not exist in our Documents folder, and we'll have to copy it from our app into the Documents folder. So we're going to create a new method called check and create database. You do that right below did finish launching. So I'm going to say func check and create database. And before I forget, the second last line above return true for did finish launching, I'm going to call this method. I'm going to say check and create database. So I have it there. So now inside check and create database, I'm going to create a Boolean variable, var success, set it equal to false. And what we'll do is we're going to check to see if the file already exists. We need access to the file manager object, so we're going to say let file manager equal file manager with a capital F dot default. And we'll say success equals file manager with lowercase f dot file exists at path, and we'll say database path with an exclamation mark. Now, if the file already exists, success will be true, and we can exit out of this method. So we'll say if success, then return. Otherwise, it's our first time run, which means we have to figure out where the file is and copy it and paste it essentially into our Documents folder. The file, when it's built, will reside in this file right here, my SQLite database app.app. This app file is where all of our resources are, whether it be images, in this case a database. We need to figure out where in this file that file is, my database.db, and rip it out and paste it into our Documents folder. So to do that, we're gonna say let database path from app equals bundle dot main dot resource path with a question mark dot appending insert our slash plus database name with an exclamation mark. So this variable database path from app will tell us where inside the app file our file is. Think of it as a zip file where let's say in Windows you open up, you try and view your zip file in Windows Explorer. You can actually navigate it like a regular file system, and typically the files are all in place as you would expect it to be if you were to unzip the file. So in a nutshell, we have our location for where the file is. All we have to do is just copy that file into our Documents folder. So we're going to say file manager with lowercase f dot copy item. We'll use the second one which says at path to path. We need that one. So we'll say at path, and which is basically from, so database path from app to path, database path. And it'll want some exclamation marks. In fact, let's put them in. And at this point, either way, the file exists in our Documents folder, so we can return. But it's giving us a complaint. It's saying, and let's just read it out, it's saying the call can throw, but it's not marked with a try, so no error is handled. Now, we'll just say try with a question mark, and we won't worry about the catch or anything like that. There's no need for that right now. So we'll say try, and that'll make the error go away. And we're already calling this method. So now, we're ready to go, ready to interact with the database. So now our next step is to read data from the database. So now our next step is to read data from the database, and we're going to need to bring in a framework for SQLite so that we can interact with the SQLite libraries and then interact ultimately with the SQLite database. So I'm going to go to my project settings, and at the bottom where it says linked frameworks and libraries, I'll hit the plus sign and I'm going to search for SQLite, and we'll bring in both. Hit add. So now I have SQLite 3, the library and the framework that I can use to now interact with the SQLite database. So now I'm going to switch back to app.delegate.swift. At the top of the file, I'm going to import SQLite 3. So now I can start using the functionality for interacting with the SQLite database. Now one thing to note is that the SQLite 3 libraries use C functions. And in Objective-C, when you were doing this, it was very messy because you're dealing with double pointers and it was very, very ugly code. And I will say that Swift has made things a lot more cleaner and easier to use, and it's a lot nicer to interact with C and Swift as opposed to Objective-C and C. So that's kudos to Apple for doing that. So what I'm going to do now is I'm going to create one more method. We'll do it above check and create database. I call it read data from database. Read data from database. So we're going to make our read here. And before I forget, inside did finish launching, just below check and create database, I'm going to say read data from database. Alright, and that's it for my did finish launching. Now it's up to me to create write the code that will interact and read from the database table. So first thing I need to do is I'm going to empty out my people array. Just in case if I want to call this a second time, I don't want to have duplicate data, so I'm going to say people dot remove all. So my people array is empty. Now I'm going to need a variable to point to the database object itself. So I'm going to say var db extends opaque pointer. That's a nice little object, wrapper object for C objects that was created by the engineers that created Swift. So set equal to nil. And we'll say, now we want to open up a connection to our database. So we'll say if SQLite 3 underscore open. Now we're going to point it to self.database path. And we'll pass in the memory location of the DB object, so ampersand DB. We'll check to see if it's equal to SQLite underscore OK. Now, if it fails, then at least we can put an else statement in. We'll just print to the console our errors, so we'll say print, or sorry, else print unable to open database. But otherwise, if we get an OK, then we can go ahead and take a step further. The next step would be to set up our query. But let's also do a print statement to the console just to verify things actually worked. So we'll say print successfully opened connection to database at, and then we'll put slash self.database path. Alright, so we'll print out database path in case you need to do some debugging through the console. We can see it there. Now, to set up our query, we need two objects. First, we need an object called a query statement. It's of type opaque pointer as well. So we'll say var query statement. of type opaque pointer, set it equal to nil, and we'll need a variable for our string, our query string. So we'll say var query statement string extends string equals select star from entries. Make sure you have your table name correct, otherwise this won't work. So my table is called entries, so I'm going to continue with select star from entries. No need for a semicolon, not needed at all. Next step is we're going to basically malloc up some memory for this query statement object and embed our query statement string inside of it. So we're going to use a function called SQLite 3 prepare v2. So let's say if SQLite 3 underscore prepare underscore v2, passing in our database, so db, that's the first argument. Our second argument is our string, so query statement string. Our third argument is how many bytes do I want to limit this transaction by. I'm going to say -1, meaning no limit, just give me all the data. Next argument is the memory location for my query statement object, so ampersand query statement, and we'll put nil for the last argument, no additional data needed. We'll check to see if it equals SQLite underscore OK. We'll put an else just to say unable to, so we'll say else print, we'll say select statement could not be prepared. Now we can go ahead and do our query. So at this point, if we're inside the if statement, we can go ahead and query and do our select. Now we're assuming we're receiving back more than one row, so we'll do a while loop. So we'll say while, and the function we need is called SQLite 3 underscore step for query statement. So while there is a row, essentially, so we'll say equals equals SQLite underscore row. Alright, so while it's a row, that means there's a row to deal with. Now, we have to extract a row, and we're going to embed it inside a data object, and then put that data object inside our people array. So to do that, we're going to say let id, which extends int, equal, we're going to use a function called SQLite 3 underscore column underscore int. And if before I put the word int, there's a bunch of these column functions. So there's column int, column blob if you want to just embed images directly into it, column name, column text, type, bytes, and so on. We're going to take column int for our id column. We'll pass in query statement and which column number. So my ID was at column 0. Now it's going to want me to cast it to an int. So I'll say int of this, because it's probably looking for a lowercase int. We'll say let cname equal SQLite 3 column text also query statement, but column 1. We'll do the same for email and food. So column 2 for email. Column 3 for food. So at this point we've got our ID, our name, our email, and food. Let's convert them into regular strings, because right now these are C strings that we have here. So they're not compatible with our object just yet, so let's convert them by saying let name equals string of C string, passing in cname. Let email equal string of cstring for cemail. Let food equal string of cstring for cfood. Alright, so we have cname, cemail, cfood. And of course it wants exclamation marks for all three. Now finally we can embed it inside our data object. So we'll say let data extends data. We'll instantiate so data.init. And then we'll say data.init with data, passing in row, which is ID, name is just name, email is email, food is food. And then finally, people.append for data. So now we're adding in this newly created data object for our array. But let's also, for debugging purposes, print out the row number that was received. So the row data that was received. So we'll say print query result, and then print. We'll say /ID, little piping character /name, another piping character /email, another piping character /food. Alright, so at least it'll print out the row by row result. But we're not done yet. We need to do some cleanup. So at the end of this if, we need to free up the memory that was allocated. So I'm going to say SQLite 3_finalize for query statement. So this will free up all the memory allocated for query statement and flush any data that has left yet to be flushed to our file system and to our objects. And then I need to close the connection to my database. So below this else, we're going to say SQLite 3_close for DB. So now our read data from database method is complete. Now the next step is to get it to display in a table. In our table view, we created a custom object called siteCell in a past exercise. So what I'm going to do is I'm not going to recreate it again here. I'm going to jump into that past project and add that siteCell object to this project here. So I'm going to right click on classes and I'll say add files. I'm going to navigate to where siteCell is. Now if you followed along in the previous exercise, siteCell will be located in some other location. Just navigate and bring it in. Copy items if needed, make sure it's checked, hit add. Now for those of you following this for the first time, I'll just put siteCell up for a moment and you can refer back to our video on how we created siteCell when we did table cells or introduction to tables. So there was 2 videos on introduction to tables. The second one where we did a little bit more of an advanced topic on it. So this is siteCell. It just defines a primary label, a secondary label, so 2 labels, and an image view for an image icon. We're going to omit the image icon. We won't worry about icons. You can take this exercise a step further, add some images, but we won't. So we'll focus on primary label, secondary label. So now I can jump over to my table view controller.swift file and start configuring my table view to display the data I need. So move over to table view controller.swift and we need to bring in the 2 delegates, as you recall from a past exercise, to support the table. So we're going to say class table view controller extends UI view controller, comma UI table view data source. and UI table view delegate. Alright, once that's in, it's going to complain, hey, there's some methods that really we need to support the table. So we'll do that in a moment just to recap what it is. But all of our data exists inside app delegate, so we need to create a variable to access the app delegate. So we're going to say let main delegate equal UI application dot shared dot delegate as app delegate. So now we have our app delegate. And what we should do inside view.did_load is do a refresh to the database table just in case if somebody entered some new data and it didn't get a refresh into our people array properly. So we're going to say inside view.did_load main delegate dot read data from database. Now we can go ahead and create the table methods that we need to display the data from our table. So I'll do it just below my variable declaration here. I'm going to say number of rows in section. So how many rows are there in the table? I'm going to return back main delegate dot people dot count. So how many rows based on the length of the array. Now I'm going to override how thick each cell is going to be. So I'm going to say height for row at hardcode return 60. Third method is what should each cell look like. So I'll say cell for row at, and we're going to reuse our site cell object. So I need to figure out if it's a scenario where a cell is leaving the screen or if it's being instantiated for the first time. So I'm going to say let table cell equal table of view dot dequeue reusable cell with identifier. We'll just hardcode the identifier to cell. We're just checking to see if a cell is leaving the screen that we can repopulate. Now we'll cast it as site cell, but if that happens to be nil, meaning that we're still instantiating cells for our table view, we're just loading our table view up right now, put a double question mark and say site cell and instantiate it with style being .default and our reuse identifier being cell. But either way, we have a site cell object to work with. Let's get the row number for the array so we can insert the right item into the right location. So say let row num equal index path dot row. Now we can go ahead and populate our primary label and secondary label for this cell. So we'll say table cell dot primary label dot text equals main delegate dot people of row num dot name. So we're going to put the name for our primary label, put email for the secondary label. So we'll say table cell dot secondary label dot text equals main delegate dot people row num dot email. That's good enough for the table cell. Let's put a little arrow for the accessory. So we'll say table cell dot accessory type equals dot disclosure indicator. Finally, return table cell. So we've done this in a past exercise, so we've gone in greater detail about these support methods for the table. So if you feel like you need more information on it, refer back to those two other videos in Module 4. But either way, we have enough for our table. But let's take it a step further. Let's get our event handler going for the table cell. So I'm going to add another method here called did select row at, and this method will execute code upon clicking on the table cell. So let's first figure out, we're going to have an alert box pop up. So let's first figure out the row number we're dealing with. So we'll say let row num equal index path dot row. And let's recall from a past exercise, there are 4 steps to getting an alert box to appear. So first to declare the alert box, so we'll say let alert controller equal UI alert controller of, and we'll take the third one, title. So we'll say title will be the person's name. So we'll say main delegate dot people of row num dot name, and the message will be the person's favorite food. So we'll just say main delegate dot people of row num dot food. Preferred style, we'll just say dot alert. Next step is declare a button. We're going to have just one button. It'll be like an OK button with a cancel action. So we'll say let cancel action equal UI alert action. Only one object or one method stub there. Title will be OK. Style will be dot cancel because every alert box needs a cancel, minimum one cancel. Handler nil because we don't care what happens upon clicking on the button. Third step, join the alert box to the action button. So we'll say alert controller dot add action for cancel action. And finally, present it to the screen. So present alert controller. We'll say animated true. Give a little bit of a slight animation to it. So at this point, what we've done now is we've created the code to access our database and to retrieve the data from the database and then to display it in a table. We configure our table right now to show name and email, and then we click on the table cell. It'll display name and food. So let's connect things up in the storyboard and give it a run and verify that our table works. So I click on the table view itself, bring in my inspectors. I see data source and delegate. Once I highlight table view, drag and connect that to the yellow circle. Now let's give it a run. Alright, so it looks like there might be some issues. Actually no, it looks like we got Munkee at projectmqd.com and bananas. Let's see what happens when I click on view database using table. It only retrieved one row. But it successfully opened a connection and retrieved one row, which tells me that there is an issue with retrieving more than one row in my code. Let's see what's going on. So go back to appdelegate.swift. So this is where we're going to start debugging stuff. So we have here while SQLite 3 step for query statement equals a row. Now you'll notice we put the finalize statement inside our step. This is not good because this finalize statement will basically free up the memory for our query statement before we're done. This should have been outside of the while statement. So we're going to take this, cut it, paste it outside. Let's try again. Click on View Database using Table. Actually, look, we actually have our rows all displaying nicely. Now let's verify. Yep, Munkee, Llama, and Yoti are right here. Click on Llama. Llama likes hay. Yoti likes steak. Munkee likes bananas.